we've been learning about the atom, right? So you guys have been learning about the protons, the neutrons, the electrons. You've been learning about isotopes and ions. If you have any questions about these things, you guys have really got to ask me, because I won't be here next week and I really want to make sure that you are on the right path, okay? So let me know if you are confused. So you guys learned about the different models of the atom, and the type of atom that we believe visually to be the right one is the electron cloud model, which we also call the quantum mechanics model. And in these different models of the atom, you want to be able to draw them. You want to be able to show where your electrons are, your protons, your neutrons. And if you'll remember, our protons and our neutrons are in the nucleus, our electrons are in the electron cloud, okay? So when we draw electron cloud models, you like how humongous my hands look right here? All right, back on track. Whenever we draw the electron cloud model, we are paying attention to a very special type of electron. So there is this type of electron called valence electrons. V-A-L-E-N-C-E, valence electrons. These are the electrons that hang out in the very outermost energy level of an atom. So whenever you've got the little nucleus, and then moving out and out and out and out, you have different energy levels where electrons can hang out in these clouds. And so the very outermost shell is where the valence electrons hang out, and you have to know how many valence electrons each atom has in order to draw an electron cloud model. So I'm going to show you how to do that right now. It's super duper easy. So here's a periodic table of the elements, which we're going to get much deeper into soon. But to be very basic, we have a couple different parts I want you to know right now. When you look at a periodic table, you'll see that we have these vertical columns going up and down. These guys are called groups or families. So again, I don't know why in chemistry everything has two names, but we call these vertical columns either groups or families, okay? I typically use the word group, but they can also be called families. So we have group 1, this little number up here tells us, group 2, group 3, 4, 5, and on down the row until we get to group 18. And each one of these groups have very special properties, okay? So whenever we're determining valence electrons, we are going to look at the group number for the atom, okay? All of these guys here in the middle, like when I look at a periodic table, I think of like a throne, kind of. So somebody sits here, here's a little armrest, here's a big armrest, okay? We are not going to find the valence electrons of these groups that are in the seat, okay? Those are a little bit different. Those are a little bit harder to figure out, so we're not going to worry about them. The only groups we are going to figure out the valence electrons for is group 1 and 2, and then groups 13 through 18, okay? So keep with me here. If any of this gets confusing, I want you to repeat the video, because you're going to see this over and over and over again, or come up and ask me so I can walk you through it one-on-one. So let's say I need you to tell me how many valence electrons lithium has. So I'm going to look at the table. I'm going to find lithium right here, okay? Lithium. I see it's in group 1. It's in this very first row. So easy peasy lemon squeezy. Lights just went out in my room. They're not turning back on. Anyway, lithium is in group 1 right here, okay? That means it has one valence electron. Ta-da! Everything in this column only has one valence electron. If I say, hey guys, how many valence electrons does calcium have? I'm going to find calcium right here. It's in group 2. Magic of all magics, everything in this column has 2 valence electrons because it is in group 2. Super easy for these 2 rows. The number of valence electrons equals its group number. We're going to ignore all these blue guys in the middle, and we're going to come over here to 13 through 18. This is where it gets a little bit more difficult. But all you have to do over here is ignore the 1, okay? So instead of thinking it as 13, 14, 15, 16, 17, and 18, I want you to think of it as just 3, 4, 5 through 8, okay? So if I say, how many valence electrons does phosphorus have? I'm going to find phosphorus. It's right here. I'm going to figure out what group number it's in. I'm going to say Miss Burnett told me to ignore the 1, so it has 5 valence electrons. If I say how many valence electrons does gallium have? Gallium is right here. It's in group 13. Miss Burnett says ignore the 1. That means I have 3 valence electrons. The biggest amount of valence electrons that any atom can have is 8. That's the most that can hang out in that outer energy level. That's it, okay? So if I say how many valence electrons does krypton have? Krypton's right here. It's in group 18. I ignore the 1. Krypton has 8 valence electrons, okay? Okay, so what you are going to do is draw, and by draw, I mean you are going to draw on PowerPoint what these electrons are going to look like, okay, using the valence electrons. So let's say that I ask you to draw me an electron cloud model of a sodium atom. The first thing you guys are going to have to do is look at your fancy periodic table of elements that I've given you and find sodium, okay? So sodium's kind of a weird one. It's one where the name doesn't exactly match its symbol, okay? So sodium, its abbreviation is actually Na. So we look on here and we will find it in group 1, whoop, right here, okay? Atomic number 11, it's in group 1. So if the atomic number is 11, I know that it has to have 11 protons. And unless somebody tells me it's an ion or an isotope, I know that protons, electrons, and neutrons have to all be the same number. So it's not an ion, it's not an isotope. I've got 11 electrons, I've got 11 neutrons. Easy peasy. So I am going to select 11 protons, which are my red ones, 4, 5, 6, 7, 8, 9, 10, and 11. And now I need 11 neutrons. So I'm just gonna control click these guys, or not. It's not working. Actually, I'm just gonna hit shift here. Drag them over. Let's see how many I have. Jeez Louise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm gonna drag them over there. All right, so I have 11 protons and neutrons. I know I have 11 electrons, but in an electron cloud model, you are not actually going to put all the electrons on there. You're only gonna put, only gonna put the valence electrons, okay? So I have to go back to my periodic table here, and I have to remind myself that sodium is in group 1. So easy peasy lemon squeezy, I know I have 1 valence electron. So I'm gonna type 1 right here, and I'm gonna drag a valence electron right there. Okay, and that's all it is. Super easy, right? So you're gonna do that for the next couple of slides here. You are going to make electron cloud models for all of these guys. And then you are going to get, it's gonna change a little bit on you. So you can also draw an electron cloud model where you don't put all the dots in here, because that can get tedious. So one way to make it easier, let's say we have carbon, okay? And I know by looking at my chart, and because it just tells me that carbon is right here. It's in group 14, okay, number 6, group 14. So because its atomic number is 6, I know I've got 6 protons, 6 electrons, 6 neutrons, because they're all equal unless I specifically tell you it's an ion or an isotope. And then, because I said, where is it? Carbon, right here. It's in group 14, right? We ignore the 1, and we know there's 4 valence electrons. So then instead of dragging all those dots, we'll put 6 protons, 6 neutrons, 6 electrons, and then I'm just going to drag 4 of these valence electrons right over to the cloud. All right, so go ahead and give those a shot and let me know if you have any questions.